Okay, we're getting the same old notification. Okay, so welcome to week 9, session 7 of JavaScript chats. This is going to be the final section of JavaScript chats this quarter. And today we'll be talking about TypeScript. And we're here with Omar, one of our participants, who is going to take us through what TypeScript is, what's the motivation, and some of the basics of TypeScript. So, yeah,
Alrighty.
Omar, do you want to introduce yourself a little bit first before I go to logistics?
Yeah, I think so. Hey, everybody. My name is Omer. I'm a recent transfer admit, so hopefully I'll be studying at UCLA with a major of computer science. We fall 2021. And yeah, that's pretty much all the description there needs to be.
Cool, cool. And here are the logistics. So the slide, the README, and the attendance code are all here. I'll also copy this to a slide. Give me just a moment. Okay, I should also disable waiting room. Okay. And second, I will copy the links into the chats. Okay. So here are the links. Oops, 1 second. Keyboard stopped working. So here's all the links that you will need. And um, I'll give everyone like 30 more seconds if they need to grab them. Okay, if that is the case, I'll just hand the presentation to Omar then. And I'll stop sharing. Omar, you can share your screen.
Yeah, sounds good. Um, okay. Does everybody see my screen? Does everybody hear me okay? Everything's good?
Yep.
Awesome. So, hey everybody. Today we're going to be, well, first I'll just introduce the event. This is week 9, session 7 of JavaScript chats. Today we're going to be talking about TypeScript, specifically what it is. Like Galen said, we're going to be talking about the motivations behind TypeScript, what exactly it is that TypeScript is trying to solve, why we should care, and then also we're going to jump into some actual TypeScript code. So before getting started with TypeScript itself, just take a look at this, this utility function here. So relatively self-explanatory. We have this getUserGreeting function. It's going to take in a first name, presumably as a string, and it's going to return a sort of string interpolated version of that. In other words, just as a greeting, you know, if I pass in Omar, it's gonna say hi there, Omar. Relatively simple. But let's say we want to refactor this, right? In this case, let's say that if the user is close to their home, if their current location is close to their home location, we want to say welcome home, right? So we want to refactor this. And for that, we're going to take in a user object now instead of a string. And this is going to allow us to make further refactors as well. So if you're thinking of the motivations behind why we might do this as a design pattern. But we have this other piece of our code that we didn't consider, right? So we have const greeting, we're creating a variable, we're setting it equal to the return type of, you know, this function call here, and we're passing in a string. Now, this functionality is unfortunately deprecated at this point. We're expecting a user object, so we're getting some unwanted behavior here with hi there undefined. Now, this is relatively simple to find. This is just presumably in the global execution context. There's no problem in finding and debugging this. But what I want to convince you now is that it can be a lot harder than this to actually notice this bug before it gets pushed into production. So this is what's called a type safety error, and the basic reasoning behind why these happen in JavaScript really boils down to two main things, two main properties of JavaScript, you can say. The first is that JavaScript is dynamically typed, meaning that we don't enforce what a variable or in this add example, a parameter to a function. We don't enforce what types these are. And so JavaScript just runs with it. It doesn't enforce anything. We can create an array that stores a number, undefined, not a number. It can store a function. There's really no limitations here. And secondly, JavaScript is an interpreted language, so there's no compile step to check our code and make sure that we're not doing anything silly here, right? It basically just runs, and then we figure out in runtime if anything occurred. Now, the previous example is actually relatively simple, right? This was immediately executed, but not every piece of code is going to be sitting in the global execution context, right? So imagine this sort of code snippet here. We're in the context of a browser. We're pulling two elements from the DOM. We're adding a event listener to this button. In this case, it's a click listener. And then we're setting this other element's inner text to basically include a greeting in some way. So we're consuming the same function. But once again, as you can see, where it says current user.firstname, we're passing in a string that's now deprecated, right? And this is going to result in the same type of error we saw before. And if we take a look at this other example, here we're in the case of a server, so Node.js server, presumably. We have an express endpoint. We create a router. We set an endpoint for slash user greeting, which is accessible through a get method. We pass in a callback. Exactly what this does isn't really important. The important thing here is that we're returning a greeting, but this is within a callback, right? So this isn't executed immediately. When we run our code, we're not going to notice this, right? This isn't going to print out hello there undefined to our console. This isn't going to throw any error, right? So I want you to think of just how easy an error like this might slip into production, right? This can't even be solved with unit testing here because the function works completely fine, right? It's the way that we're using the function that's an issue here. So this would require integration testing or end-to-end testing, which is really costly, and presumably we don't have full coverage using integration testing. So this can very easily slip into production, right? Now a little bit about me. I know I gave a really brief introduction before, but hey everybody, my name is Omer Demirkan. I just go by Omar with an A. I'm an incoming CS transfer from Los Angeles Mission College for this fall, hopefully class of 2023, fingers crossed. I am a current software engineering intern at a company called CarpaMed. I like pineapple on my pizza, and I like static type checking on my JavaScript. Now, my introduction with TypeScript really started when I first got into an internship. I think it was the summer of 2020, sorry, the spring of 2020. And I did an internship as a web app developer for a company down in San Diego. And for that position, I had to learn this framework called Angular. And while Angular had its sort of pros and cons, one of the pros that I got from it was this really interesting thing called TypeScript. And so I've always run across these sort of type issues before, to the point where it actually started changing the way I code. Right, I was now sort of afraid to refactor my code in fear that it was going to break something else. Right, so I was afraid that if I change this, there's going to be some type safety error somewhere else, and I'm going to feel the repercussions of it. So I would start actually just ripping code out of my project and rewriting from scratch just because of this. And so it goes to show just how much effect these sorts of errors can have. And so when from the lens of Microsoft and their ecosystem came this promise of type safety in JavaScript, I was really intrigued, and I believe I was introduced to TypeScript a little bit over a year ago, and for the most part, I've found that it lives up to this promise of bringing type safety to JavaScript. Now, there's actually a lot of hoopla on what TypeScript is, and there's naturally with that there's a lot of confusion. So I want to specifically talk about what TypeScript is here, in detail, so we know what we're getting ourselves into basically. Firstly, TypeScript is a static type checker. Now, what the hell does this mean? What does static mean? Very simply, we're going to, if we use TypeScript, write our code in TypeScript, and the TypeScript compiler is going to statically analyze our source code, and it's going to tell us when we've made any discrepancies. So this can mean, if we have our self-defined types and then we have our code, it's going to tell us, hey, we found a contradiction here. You're not using this like you should, and it's going to let me know that before I compile, right? Next, I've alluded to this. TypeScript is a compiler. So we're going to have access to this command called tsc, and this sort of acts pretty similarly to GCC or JavaC or any other popular compiler. This is going to convert our source code from TypeScript, except it's not going to do it like you might think a compiler does it. It's not going to go down to any sort of x86 or WebAssembly. The target for this compilation is going to be specifically JavaScript. So if you were wondering, what the hell does TypeScript have to do with JavaScript? Why am I hearing about this in JS chats? This is why. I would argue, in fact, that TypeScript is a JavaScript development tool. It's not a separate language, in my opinion. But if you see on the right, we have our source code, and then we have a build directory that TypeScript produces. It sort of is a one-to-one mapping. Now, this is in the context of a server, but you can very easily set up the compiler so that it integrates with like Bundler, like Webpack or something, to basically get it down to a manifest.json or a single file that can be run in the browser. Next, TypeScript is a strict superset of JavaScript. Now, this is very popularly, the first explanation of what TypeScript is. I would argue this isn't the most important, but it's an important thing to know. When we talk about strict superset, this is what we're really meaning. If you imagine some sort of abstract space of all possible strings of characters, a certain set of that is going to be valid JavaScript. And a certain superset of that is going to be valid TypeScript. Now, what this means for the developer is that all valid JavaScript is valid TypeScript. This is one of the biggest selling points in that it doesn't have very many cons, right? All of TypeScript's features are pretty much opt-in. So this allows for sort of incremental adoption, if you will. Next, it's supported by many frameworks. This is going to be either, literally a section in the documentation of the framework titled TypeScript, where it shows you how to switch a project from JavaScript to TypeScript, or how to start a project in TypeScript. Or this is going to be in the form of community provided types, pretty similar to what would be in Express. Now, I know React isn't a framework, but don't bully me. Next, TypeScript is loved by developers, and I think this is really the biggest selling point, is that type safety, it's all well and good. I think types account for about 20% of the, I should say lack of type safety accounts for 20% of the runtime errors in production. But more importantly, it provides an incredible developer experience, right? I mean, the top right is just an example of property chaining, but there's so many that we're hopefully going to get into today. And on the bottom right, we have a Stack Overflow survey. I believe this is from 2020. That shows that TypeScript is the second most liked language, and that's ahead of, let me see, Python, Go, Dart, Swift, even JavaScript. So it's liked by developers who use it. Gillen, if you can help me out. I think I can run a poll as well. Let's try to run it. So we're going to start off with a poll on what exactly is TypeScript. I'm having trouble. Okay, so I want you to go through these sort of one by one. This is sort of true or false. So just go through these one by one. Think, does this apply to TypeScript? Does it not? And I'll be quiet so everybody can do this at their own pace.
I just launched it.
Got it. Awesome. Okay, it's been about a minute, so okay, awesome. Let's end polling and let's share results and go through these pretty quickly one by one. So first, there's TypeScript is an independent alternative to JavaScript. This is pretty much completely false. There's no real argument as to why this would be true. So this is basically due to the fact that there's no real TypeScript, there's nothing that runs TypeScript per se. There's no TypeScript interpreter. So basically, what TypeScript does is it compiles to JavaScript, and then you can run that JavaScript. Next, there's TypeScript as a compiler, and then there's TypeScript as a transpiler. Both of these are true. You might actually hear these terms thrown around pretty interchangeably, but just know that in the context of TypeScript, they both mean the same thing. And I guess the reasoning behind why this happens in the first place is that it's pretty hard to tell if TypeScript is at a sort of higher or lower level of abstraction than JavaScript. Some people say it's the same, so they think of it as more of a horizontal movement rather than a vertical one like C++ to x86. So it's used interchangeably. Next, we have TypeScript is, TypeScript is a tool for dynamic type checking. This is actually false. So TypeScript is only a development tool in that it statically analyzes your source code beforehand, and then it compiles down to JavaScript, and that's actually what your sort of distribution. It doesn't work at runtime. All valid JavaScript is valid TypeScript. That's true. TypeScript has a steep learning curve. This is actually false. And these last two actually are related in the fact that TypeScript is a strict superset of JavaScript. Because, since all valid JavaScript is valid TypeScript, what this means is that it allows for incremental adoption. You can learn TypeScript in the matter of 6 months. You can learn it in 3 days. Lastly, TypeScript should be used in every JavaScript project. This is going to be false. So let's stop sharing results. So let's look into exactly why that might be, because there's actually a bit of there are pros and cons, obviously. There's some overhead to using TypeScript. For example, if I want to switch to TypeScript, I'll have to, first of all, get it to work, with the compiler. Next, I'll have to actually write out my types. And these two alone, if your project is extremely small, like within the span of 2 or 3 days, this might not be worth it. So you do have to consider a little bit of the overhead. But I find that if you have large-scale projects, TypeScript scales really well, and the pros and cons are pretty simple to determine. Okay, so we're going to talk a little bit about some real-life examples. So I have a Node.js and Next.js example on my local machine. First, we're going to go over how exactly it is that this compiler statically analyzes my source code. Then with the Next.js example, we're going to go over IDE support, some actual tooling that you get in an IDE that supports TypeScript, how TypeScript infers types, and then we're going to go just a little bit into how we can use TypeScript in the context of React. Next, we're going to actually set up TypeScript on our local machines. And this is going to be relatively quick. We're going to then learn some language features, what exactly it is that TypeScript provides, instead of just sticking within that subset of JavaScript. And then we're going to talk about, how TypeScript relates to, community packages and how it relates to NPM. So first thing that I want to do is I want to show you a sort of real-world example. Now, we have this sort of function that's get token payload. And what this does is, in my server, I want this to encode a certain object into, I should say encrypt, into a string that users can use for validation. This is called JavaScript Web Tokens. The semantics aren't important. What's important is that I have this utility function that I have dedicated to this task, so that it sort of, I don't have any concerns about, how did I create this token payload correctly? Since it all goes through one funnel, I'm pretty certain of the shape of token payloads. But that's neither here nor there. So we have this function, get token payload. This is going to accept a object of type user. And I'll talk a little bit about inputs and outputs and how we define them later on. But just know that we're defining our parameter as a type user. And then we're returning a token payload, which is what we're going to store eventually as JSON into a JavaScript web token. So let's say, for example, that I don't want this property here, right? It doesn't really serve a purpose. There are no other properties, and in JavaScript web tokens, the smaller the JSON is, the better usually. So what I'm going to do is I'm going to cut this out and place this into the sort of root object. And what this is immediately going to do, since VS Code has great TypeScript support, if I hover over it, it's going to say type yada 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 is not assignable to type I token payload. And this is because I've defined the return type as this. So what I'll do is I'll do the same change here. And this is basically a description of what my token payload should look like. An ID as type string, first name type string. You get the idea. But let's actually try to run this. So I have a dev script in my package.json, and I'm going to run this, and let's see what we get. We get a sort of error, and I'm pretty sure you can tell why I'm showing you this. It's saying property user does not exist on type iToken payload, and it's giving me this sort of directory on my local machine. I'm going to control click it, and it's showing me, okay. So from this, I'm trying to access the I guess payload on this request object in a way that isn't like necessarily supported anymore, right? We don't have this user property on our object anymore. So in runtime, what this would do is would say, property role on type undefined doesn't exist, or something along those lines. I'm pretty sure you're very familiar with it. And so what this just did is this was completely valid JavaScript, right? If this was a .js ending instead of .ts, this would work completely fine, minus the type declarations. And I could presumably push this into production. What TypeScript does for the developer is it analyzes my source code and says, hey, you've made a contradiction here. You should look into this, right? And so what does this do? Well, basically, I have the change that caused this error in my mind, and I can fix it within a matter of, I don't know, 30 seconds, right? Just going through these one by one, I know exactly what's causing this problem. But what if we didn't have JavaScript, right? What would be the alternative? Well, best case scenario, this would go into some continuous integration step, and we'd get a notification from, I don't know, Circle CI, like 2 hours later saying, hey, there's this error from your integration tests, you should check it out. And so you have to go back and play Sherlock Holmes, basically, trying to find this error. What did I do to cause this? And try to remember what you wrote back like 3 hours ago, right? In worst case scenario, this will get pushed into production, right? And it'll cost, I don't know, X amount of dollars. Your project manager will be pretty angry, and so on. So this just shows you how powerful TypeScript is, right? I'm giving the type checking sort of role to TypeScript, and so I don't have to think about it anymore, and I don't have to worry about type safety issues. Now, there's a way to write TypeScript so that you don't have to worry about them, but we'll get into that in a bit. Next, we're going to go over the Next.js example. Now, once again, the semantics aren't important. You don't have to be familiar with every piece of code here. The important thing is, so there's this use SWR hook here in a React context. And very simply, this is going to act as a data fetcher. And for those curious, SWR is a sort of alternative to Redux, but I won't talk about it too much. I would look into it if I were you. And so let's hover over this courses object here. So it says const courses : I course, open bracket, close bracket. I'm pretty sure you can tell this is an array of courses, if you will. But how did TypeScript know this, right? Like, where in this did I say this was a course array? Let me actually, I course. Like, where did it get this from? This is very strange, right? So let's do a little bit of digging. If I hover over this user courses fetcher, that seems to be the reason why. And sure enough, this is a function that returns a promise that resolves to a course array. Right? So let's go into this. So I just control clicked and one of the features of VS Code. And let's look deeper. So this function uses a function. So it's a bit of a closure. And this is going to return a promise that resolves to an API response with the data being a course array. Let's go to this function, right? This seems to be sort of wrapper around another function, just sort of overloading it. And here we go. So we seem to have found where this course array thing is coming from, right? We have this function here that's returning a promise that resolves to yada yada yada. We've defined it here basically. If I control click this in VS Code, we're going to get this sort of object description, what this object should look like. And so I've written this once, right? I've only, declared a return type on this function here, and all the other functions, that we're using it didn't really declare it. And all the way back, if we look, it's still course array, right? So this just goes to show how little you can declare types and how strong TypeScript can infer, how good its interpretation of types is. Now this is all well and good, but why would we want this, right? Course array, that's cool. Let's look at some of the tooling that this provides. The fact that my IDE knows the shape of this is actually going to be pretty important. So I'll say courses. I'm going to say dot, and here we have a lot of the properties. I'm sure you're familiar with them. They're in the form of an array. Let's use them. Filter course. I'm going to pass in some function that filters, returns true or false. So I'll just say new date. So I'm going to say filter the ones that are after today, right? So going to say get time. Let's just say new date dot get time. Not particularly efficient. That's not what we're looking for. Should be less than. So we're filtering for ones that are, let's say, before today. Let's say dot. I don't want to filter again. Let's go to the first element. Let's say dot. Okay, cool. We have some properties here. Let's go meetings. Let's map this. This is actually getting out of my screen. And you sort of get the idea. I don't want to be too repetitive here. Let's try extracting some of the properties here. Control space, and we're getting a lot of this tooling, right? And it just goes to show how little typing, we did. Maybe we just typed basically, gave a description of the course, what it looks like, and then we've typed one, basically just one function that gives a return type of that, and it inferred that 3 levels down, right? And let's say, for example, let's actually finish this. I don't know. Let's go back and let's change this, right? So let's go, I don't know. I don't like meetings. Let's rename it to classes or something. Let's save. And notice that VS Code is saying, hey, something's up here. You should probably take a look. And if I hover over this error, this is actually, it says property meeting does not exist on type iCourse, right? This is the tooling that TypeScript provides. I no longer have to think about this, right? Like I have maybe 2 brain cells. I don't have to manually go and force them to think about this. I can worry about other stuff, right? I can focus on the actual logical aspect of development. That was just a little bit about some actual TypeScript in action. Let's actually really quickly look at a React example. I'm sure you're familiar. A lot of the people here know React. The other example wasn't too much to do with React. Let's actually look at one that's specific to it. So we have this function chat interface. This is basically going to have a chat feed and a chat input. And so let's look into this chat message input. And it seems here that, okay, it seems to be we're declaring a type. We're calling it iChat message input. It seems to be, we seem to be anding this with something. We'll go over that in a bit. And we seem to be declaring the props for this and passing that down to this functional component type that React provides as a generic. So let's actually remove this and see what we get. Save this. We immediately get an error, right? It says type empty object is not assignable to yada yada yada, and I can go to this here, and I can see, oh, I need to pass these in. I can here just control space. I can look at exactly the type I want, right? So let me undo that. And furthermore, if you might be thinking, we can do this with prop types. Not necessarily, right? In prop types, you're only sort of notified when you're sort of consuming the function, but not necessarily when you're using these actual things. So let me, for example, go and say on. The demo gods are not with me today. So on send message, I don't know. I'll go some property that doesn't exist, and I'll try to call that. Let's save, and we get an error. Property does not exist on type yada 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 function that takes in a string and returns anything, right? And further, we've actually taken some other type that we gotten from Material UI, and we've sort of anded this. Now we're going to get into this in a bit, but this is basically saying use this as a base. Sort of, you can think of extending this, and then add these properties on it. And so one thing you can't get from prop types, if I control space here, you see I'm actually getting all the other properties of a Material UI text field, right? I don't have to manually go in and define them. And more importantly, when I update Material UI, I don't have to go in and update these types manually, right? So I can go, I don't know, let's pick something, input props, right? This is going to take in an object, control space. My PC is kind of slow, my apologies. I don't know, let's change color. Okay, this is going to expect a string, and we get the types here. So it just goes to show, how far just a little bit can go. If you invest some time properly typing everything, you're going to get some amazing tooling. Awesome. So I think I'll leave it. Let's actually first configure TypeScript on our local machines, and then we'll take a 10-minute break, hopefully. So I'm going to open some directory. So I just have some empty directory open here. And this is the actual code along portion if you want to try things out. And let's actually try to install TypeScript. So first thing, as a sort of prerequisite, you're going to need Node.js. So you can do that by checking Node-v if you have it. Same with npm.
Omar, make
Yeah.
the terminal bigger.
Yeah, let me do that. I just switched to Ubuntu. I'm sorry, I can't. Yeah, I can't seem to be. My apologies.
Can you click like the menu again and then the percentage? Does it work? Like the
percentage. Awesome. Yeah, you got it. Wait, is this bigger?
Yeah,
PM?
can you try like making it a little bit bigger as well? Like, oh yeah, this
Okay,
is fine. Yep.
got it. Awesome. So for the remainder, we solved a bit of an issue. Thank you, Gail. Okay, so we can check if we have TypeScript installed, Node.js installed. We can do the same with npm, just to make sure that we have everything set up. The actual version numbers aren't necessarily important. What's going to be important is that basically they're there, and that it's not horrendously outdated, which is very unlikely. So now that that's set up, we can actually install TypeScript. So what I'm going to do is I'm going to say npm install, and you would normally install this as a development dependency. And so you would have some continuous integration step actually build this for you. But for the purposes of this, I'm just going to install it globally. So -- global TypeScript. Whoop. There we go. Oh my God. Okay. So for those who are in Linux or Mac, you're going to have to prepend this with sudo because this does require some privileges. So I'm going to type in my password. I already have it installed, but just for the show. So let me actually paste this into chat. So hopefully everybody has the right script. Whoop. Awesome. So you can run that, presumably if you have npm installed. And now we're pretty much ready to try it out, right? So you can create a TypeScript file anywhere. You can actually open it with anything. Like there's no limitation on what exactly you have to use. But for the sake of this presentation, I'll be using VS Code, just because Microsoft created VS Code, Microsoft created TypeScript. It has good TypeScript support. 1 + 1 = 2. So let's actually take a look at this. Now, what I want to do here is actually create a very simple hello world program, just so we can make sure that everything is set up correctly. So we can say console.log, I don't know, hello world. And let's go back to our terminal. And what I'm going to do here is I'm going to run our TypeScript compiler, and I'm going to target this index.ts file. Right, so let's try that. And it's done running. And we have this index.js in our directory now. And this I can actually run. So I can say node, and we can run this, this JavaScript file. Right? So relatively self-explanatory. If we look at the input, it's basically the same thing. Once again, all type annotation features are optional. We just wrote plain JavaScript here. So that's all right, but it can be pretty annoying to have your TypeScript and JavaScript sort of in the same sort of level, right? For example, if I have a full-scale project with a bunch of directories, I don't want my JavaScript to be sitting with my TypeScript. It can get confusing pretty quickly, seeing as we don't actually produce the JavaScript output. So what I'm going to do is actually I'm going to create a way to basically have them in separate directories. And the way I'm going to do this is actually using a tsconfig.json file. Now, very simply, the way TypeScript compiler works is it can take arguments from here, like it did before. But we can also provide default arguments in the form of a JSON file in the directory where you're calling it. And so this can work as, reducing boilerplate and, rewriting the same script over and over. We can just run TSC if that makes sense. So what I'm going to do is I'm going to run npm, npx, important distinction. For those not in the know, npx is basically like npm, but instead of installing it on our local machine, we're running a script basically. And so npx tsc, and I'm going to give it an init flag. npm tsc init. Hopefully that's legible. So this creates a tsconfig.json file here. And if we look into it, we have some default options here. For example, we have target, which says ES5. This is basically going to be what TypeScript compiles this to. And you might be thinking, why the hell would I declare this? Obviously, it's JavaScript, but there are different specifications. So in this case, we're compiling it to ES5 because we want to, I don't know, support a lot more browsers, right? If we said ES6, you get like 95, 96% of browsers, but ES5 is supported by practically every browser. And so that's an additional benefit of having a compiler, is being able to write the most recent JavaScript specifications, even ESNext, something that might be supported by only 20%, and having it compile to ES5, which is supported by practically every browser. Next, we have module. We're not going to go over all of these, just a few of them. This is going to describe your module syntax. Pretty self-explanatory. Strict equals true. This is actually a really big one. This is basically telling TypeScript how how strict it should be, if that makes sense. We're going to go over what exactly this does in a bit, and the rest of them aren't really too important for this for the time being. But what I'll do, you might notice that there's a lot of things commented out. There are actually two important ones that we need. So we need root dir, and then we need out dir. This is going to be the directory for our TypeScript source code, and then the output. So I'm going to say src for source, and for this, it can be you can do literally anything. I'll just say let's say build here. I'm going to save this, and okay. To make sure everything works, I'm going to firstly delete my index.js. TypeScript creates this automatically. And I'm going to create a new folder, source, and I'm going to move my index.js into that folder. Right? TypeScript seems to be mad at something. I'm not too sure what. If something like this happens and you can't really tell why TypeScript is mad, you could just Control P in VS Code, basically opening sort of greater than symbol, I guess you can say, and then you can say restart TypeScript server. This happens from time to time. It's not too big of an issue. Now we have our source code in our source directory, I guess you can say. Let's run this TypeScript compiler once again. Now this time we don't have to pass in anything because we have already defined everything in the tsconfig. So let's just run tsc. And this compiles it for us, right? So once again, if we look in our directory, now we have this build directory sitting here. And once again, we can run this. So we can say node build dash index.js, and then we get hello world, right? Relatively self-explanatory. If we look at the source code, we have use strict is a result of setting this to true. This actually has multiple effects. I won't get into too much. Okay, cool. So we have everything set up. We have the TypeScript compiler working. I think now is a decent time to take a break. So hopefully, let me do this. Go here. I'll say, I don't know, come back at, let's say 6:55. And so hopefully we'll get into some of the actual features of TypeScript and then a little bit about how it interacts with libraries. So yeah, so see you guys in 10 minutes, hopefully. Alrighty, guys. So that's been about 10 minutes. Let's. So I guess a quick recap on what we did just before. Pausing was we went over why we need to use TypeScript or should use TypeScript, what the purpose of it is, some examples of projects that use TypeScript, some of the benefits we get from it. We talked a little bit about setting up TypeScript on your local machine, and that's just about where we left off. Let's actually check out the source code here. So where we left off was we built a source directory, and then we had a build directory that TypeScript created for us. And it's essentially converting from this to this. This is sort of one-to-one mapping. And as we continue, I don't necessarily want to run this TypeScript command over and over, as short and beautiful as it is, just 3 characters. It's not something that I want to do. So what I'm going to do, hopefully you can see at the bottom, I have a VS Code terminal open. I'm just writing tsc -- watch. And what that's going to do is, in our source directory, it's going to listen for saves. And then if it detects one, it's going to run the TypeScript compiler once again. So I'm going to run this, starting TypeScript compilation in watch mode, found 0 errors. So hopefully we're good with this step. And right now I just want to actually jump into some of the features, right? When we say TypeScript is a strict superset of JavaScript, right now we've just been sort of within the subset that is JavaScript, right? We've been, we just created a hello world program with a console log. Nothing much is interesting here. So let's actually start out with a few simple things. I want to, let's say, create an object. So I'll say me. I will give a first name, and I will give a last name. And I'll just create several more similar variables. So I'll say const, I don't know, in this case, let's say age. I'm actually going to convert these to let because I might want to change them afterwards. So I'll say let age equals, I'm 20, so I'll write 20. Let's create let mood equals happy. And let's say, I don't know, coordinates. So I'll say coordinates. I'm going to give this as a type array. So I'm going to say, I don't know, 1, 2. Let's save. And let's look back at our JavaScript. Everything seems normal. Let's actually hover over some of these. So if I hover over this, we get age, number. We start to see sort of TypeScript inferring things. Let's actually try to change that, right? So let's say, I don't know, age equals undefined. Let's try to save that. If you look at the terminal, we're getting this sort of error. This is going to be a recurring theme throughout this, so just letting you know. So there's type undefined is not assignable to type number. This might be strange when coming from JavaScript, right? That's essentially because we've set this strict property to true. TypeScript is saying, hey, I'm inferring this number, this variable as a number, and you're changing it to something that isn't, right? And this isn't something special to undefined. I can change it to a string, and it'll still not like that, right? But let's say, for instance, in this case, like that's exactly what I want, right? I don't want things to be other than a number in the case of age. But let's say I define this later on, right? So I should say initialize this, right? I don't want to necessarily initialize this immediately for some reason. Let's, for example, change these. Now, if we look at the same thing, if we hover over age, we get let age any. Now we immediately see that TypeScript isn't really inferring a type here. It's saying this can be anything, and you see that within the validation, there really isn't any here. So I can set it equal to hello. I don't know. I can set mood to I don't know, 42. I can set chords equal to not a number. and some function that I want to define, right? And it's not really type checking right now. It says found 0 errors, and this is reflected in my JavaScript, right? So we get a sort of lack of type annotation here. But what if I actually want to enforce, for example, the age be a number? The way that I can do this is I can just go to this variable. I can say colon just after declaring the name, and I can say number. Now, if we try to save, we see type string is not assignable to type number. And so we actually have to do something about this now, right? So for the time being, I'll remove it. Let's do the same with mood and coordinates. Let's say we want to strongly type these, right? So let's say mood can only be a string. Coordinates, we can actually type annotate tuples in JavaScript. You know, some of the people coming from Python are sort of sad to not see tuples, but with TypeScript, we get a sort of abstraction over arrays that allow us to do it. So I'll say number here, and I'll say number. So there are these sort of primitive types here, like number and string. Here, to define a tuple, we sort of have a array syntax, and then we just pass in the shape that we want. And this seems to be working pretty well, right? If I save, we said type, function that resolves to void is not assignable to type number for this for these coordinates. Let's say, I don't know, 5 here. Let's, I don't know, remove this for the time being. Let's save. Not a number is actually the type of operator returns number. So the same thing you would expect at runtime happens here. So you will have to be aware of not a number. I think there are some compiler configurations that you can do to avoid this, though. Okay, so all seems well and good. We have sort of declared our types so that TypeScript is not allowing us to set them equal to anything. Now let's take a look at this object that's been sitting here. So if I hover over it, it says it's in the shape of an object with properties first name and last name, both strings. And let's say that just like the other ones, I don't want to declare this immediately. Let's say I declare this after the fact. So this isn't initialized on declaration. So this is going to give us the same thing that it gave with age and mood when we didn't give it an immediate value. This is going to say this can be anything. So I'll say me equals, I don't know, what am I feeling like? I'm feeling like undefined right now. Let's save this, and there are no errors. And this, once again, shows up in the JavaScript. But let's say we do want to type annotate this, right? We do want to enforce that this me object here only has properties first name and last name, and that they be strings. The way we can do this is pretty similar to the other ones. As you might infer from this array syntax, we can do the same thing with object syntax. So I'm going to say this is an object with properties first name, and instead of an actual value here, I'm going to give it a type. First name, last name. And I'm going to save this. You can actually separate this with either semicolon or comma. This is really up to you. I like semicolons because I think the bigger differentiation there is from an actual object, the better. So if I save this, we get this error, type undefined is not assignable to type, yada, yada, yada. So we'll have to go in and fix that. For the time being, I'm just going to remove it. Okay, so we've been sort of up to date with objects. Now I want to show you something interesting when it comes to unions and literals here. So let's say this mood type, I'm not exactly happy with this, right? Because it says string, but I can pass in an empty string here. And that's not really something that I want to be a valid mood. And while you can't necessarily exclude an empty string or anything, I don't know, if we pass in like a random hash, it's going to be fine with it. And we can't necessarily exclude anything in particular. What we can do is we can be inclusive about it. So we can say, I strictly want this to be able to be happy. Now you might say, why the hell would we do this, right? Then why don't you just have a constant that you can use in runtime? The power of literal types, in this case a string literal, is that you can actually have them as unions. So let's say this can be happy. I want to add another one. What I can do is I can essentially use something syntactically similar to a logical OR operator, a single pipe, and I can essentially pass in another type here. So I'm going to make this a literal as well. I'm going to say sad. Let's just add a few more. let's add excited, and let's add, I don't know, anxious. I hope that's how you spell it, not an English major. So now we've declared that, while it wasn't necessarily helpful for us when we have one, we can actually have a union of these and have these as several different options. And the cool thing about it is I can actually go in here, specify this, and I get all the options here, right? So this is another one of those quality of life differences that TypeScript provides. Now, if I want to go after the fact and say, I want to remove excited here for some reason, and if I save, we're going to get a predictable error. Type excited is not assignable to type happy, union sad, union anxious. So if you ever want to change your types in TypeScript, you can actually feel free to do so, assuming you didn't, nullify the compiler in any way. You can actually change these and be pretty confident that nothing is going to occur. Okay, so we have these types. Let's say, for instance, that now I want to allow null. If I want to do that, I can just say or null, pretty similar with everything else. And the cool thing about this is, if I later go and let's say, I'll change this mood to null for the time being. TypeScript is actually really good at catching, if you literally turned it to null beforehand. So I'll just do this for the time being for demo purposes. Let's say we don't know this, the type of this. So I want to treat it as a string. So I could say, I don't know, index of, let's say index of space. Let's see if this includes index of space, or it wouldn't do that. Let's say H. If I save this, it says object is possibly null. So if I remove this, it's going to be completely fine with it, right? Oh, it's not fine with that. If I save this, it's going to be completely fine with us accessing this index of H. But if we add this null, it's not going to be, right? So TypeScript is basically acting as a sort of a barrier to us making these silly errors when we, add unions or when we create optional properties, which we're going to do in a bit. So this is all well and good, but you can see that there's a little bit of bloat in my application, right? I want to, let's say, I want to separate these types into a different thing, right? I don't want to write out this this thing here. What we can do is I can create a types directory. Once again, we don't necessarily have any sort of strict rule as to where you can keep anything. I just want to create my types here. And so as I've implied, we can create our own custom types. So we can say, I don't know, type age with this syntax. It's pretty similar to let or const or var. You could say type, the type that you want to do. In this case, I'm doing Pascal case. I could say equals to, in this case, I want number. And I'll do the same for the other ones. I'll actually copy mood over. Let's do this. And coordinates are relatively self-explanatory. Type coordinates equals number, number. And what I'll do here is I'll actually export all of these. So the module syntax you can determine from your tsconfig. In this case, I'm going to import with this syntax. So I'm going to say import from, I'll say types. And I can import these types like so. Oh. And you can see that when I'm sort of extracting anything from an object, or when I'm using the dot operator, whenever we're in these sorts of situations, we can actually press Control Space, and that's our one of our superpowers with TypeScript. So I've imported all of these, and let me actually replace these. So I'll say age, I'll say replace this with mood, and I'll replace this with coordinates, right? So this doesn't only cut down on repetition, this sort of is actually a good design pattern to follow, right? Because if we did this for every variable, there wouldn't necessarily be a point to type declaration, right? So we can have our sort of central types that we can then export and reuse throughout our application. This sort of allows us to, be able to expect, a certain class of things at runtime. And so let's actually create a new person. So I don't know, I'll create Galen. Hopefully he's fine with that. So I'll say first name, string. I'll type annotate the same way. And let's, I don't know, let's add him. Let's initialize first name. And you can see I'm still using this control space here. This is just a VS Code tool. So we can save this, everything's fine. But we get the same sort of issue, right? We get this repetition of types. And so once again, what we can do is we can actually declare it. For objects, there's you have actually a choice for what syntax you can use. You can use this type thing. So I'll actually just copy paste this from here. So I can say type, I'm going to say person equals this. Or if you're more sort of coming from Java or C#, you actually have the opportunity to use interface. We obviously have to give it a name. And there we go. We can export this as we like. So this acts exactly the same in TypeScript. Okay, cool. So let's actually import this. So control space, our good friend. I'm going to copy this, and I'm going to replace our type literals here. Cool. So let's save that. And now we have our sort of types separated from our source code, I guess, the code that we run that's going to be compiled to JavaScript, I guess you can say. Notice that we actually have a types.js here. For the time being, it's just completely empty with boilerplate. There are options to have interfaces act as objects in runtime, but I'm not going to get into that too much. I won't bore you with the details. Okay, so this is all well and good. This is great. Let's actually start getting into functions now. What I want to do is, if you remember at the beginning of the presentation, we started with a sort of get, I think it was get user greeting, that takes in a first name and then returns a string greeting. Let's actually implement that here. So I'll say function, get user. I'll actually say person, because we didn't create a user type here. Get person greeting, and I'll expect a first name, and I'll return exactly what I did before. So I'll say hello, hello there, and I'm going to use string interpolation. Oh, we're having a bit of typos. So I'll pass in this first name, and there we go, we have it. Now, if I actually try to save this, you can see we're getting this parameter first name implicitly has any type. So you might be thinking, well, isn't TypeScript a strict superset of JavaScript? What the hell is this? When we say that, we mean that it's syntactically valid. It's just not valid when you set the type property to true. Sorry, strict property to true. So this is TypeScript is going to be really strict with some things, and it's going to force you to type annotate a few things. Very little though. So to actually give this a type, I'm pretty sure you can imagine, pretty similar to how we did how we gave types to our variables. We're going to say colon, and then we're going to give it a type. So in this case, I want this first name to be a string, and I'll return this here. So let's save that. Everything seems to be good. Compiler's happy. Let's actually run this. So let's log something to the console. We haven't done this yet, so let's actually make sure that our code works. So I'll say get user greeting. I'm not going to pass in a person here. I'm just going to pass in their first name, right? Because it just wants its first name. Let's save this and let's actually try running it. So let's say here to run this, we can say, well, first of all, let's make sure we're in the right directory. Then we can say node. We want to go into the build directory, run index. You can say hello there, Omer. Okay, works relatively fine. Let's try this for Galen as well, just to make sure it works. Run this. Awesome. Everything seems to be working. Now let's actually try doing the refactor we did in the beginning of the presentation, right? Let's say we want to change this from accepting a string to accepting an actual user object, or in the case of this example, person. So what I'm going to do is I'm going to say person, and let's go over what we want to do first. Let's say I want to greet a person with their full name, right? First name, last name, and their middle name if they have it. So what I'm going to do is, let's comment this out for a second. I'm going to change this to, I don't know, person. And what I'll do is I'll sort of set a string array full of their first name, middle name, and last name. And then I'll extract the full one, but basically by joining those strings together. So we'll say const names. I'm going to give this a type of string array. The way you do this is exactly the same as you would give a type string, except you just add these brackets here. And that's the syntax for creating an array of something. You can set it equal to. In this case, we want the first name. So I'll say person dot first name, person dot last name. Oh, let's run this. And we want to say names dot join. And we want to separate them with a space here. Let's save this. Let's run our code just to be sure. We commented out our console log. And notice that right now we're getting a bit of an error, right? It says argument of type string. Let's say we ignore VS Code. Let's try to compile this. It says argument of type string is not assignable to parameter of type person, right? So this is a type annotation that TypeScript provides from the presentation example. So let's, instead of passing the first name, let's pass in the person object. Make sure that this works. Hello there, Omar. Hello there, Galen. Awesome. Now, what I want to do is, you might have noticed that I've said middle name, but I didn't necessarily add these, right? And what I want from this toy example is, I don't want middle name to be enforced, right? Because some people just don't have middle names, right? Like my parents, for example. But some people do, right? So I want to be able to make this optional somehow. I'm going to go to this person interface here. By the way, I'm control clicking to go to the spot in my source code. And here I want to add a middle name. So I'll say middle name of type string. Let's save this. And immediately we're getting some TypeScript errors. It seems to be mad. Let's check it out. Property middle name is missing from this object here. And so now we're not necessarily getting the functionality we want, right? Maybe I or Galen don't have a middle name. So we don't want TypeScript to yell at us for that. The way to make a property of an object optional in the type annotation, I should say, is with this syntax. You can place, oh, not that. We can place in a question mark just before the colon. What that tells TypeScript is this object type could have a middle name property, and if it does, it's going to be a string. But if it doesn't, it's completely okay. I know what I'm doing, basically. And let's actually try adding this, right? Middle name. I'm going to add in my middle name. And everything seems to be fine. I can also optionally add this later, right? So I can say middle name equals, and I can try adding something that is invalid, right? So I can say undefined, and TypeScript should theoretically yell at us. I don't know. Oh, okay. Because middle name is actually going to return undefined by default if it doesn't exist. So let's try, I don't know, 5. Now it's going to yell at us. So it's going to say type 5 is not assignable to type yada, yada, yada. So that's pretty cool. Now let's try and implement this middle name here, right? So we create this names string array in this utility function here. And then we're returning names.join, and then we're going to join these names with a space. So let's add this middle name here. So I'm going to say person.middle name. Let's try to save this. Okay, we get a bit of an error. We see type string or undefined is not assignable to type string. Type undefined will not be assignable to type string. Now, what is this telling us? Well, first off, TypeScript is saying this names variable is going to hold an array of strings. And I'm pretty sure you can see, since this is being highlighted, it's saying this might be undefined at runtime. We don't know, right? So it's basically saying you should basically check if this exists before adding this to our names array. So let's actually do that. Let's say if person.middle name, I'll optionally push this to the array. So I'll say names.push person.middle name, and I'll, oh, that's not right, names.push, and I'll push in the last name regardless, right? Let's save this. Alrighty, all seems to be well and good. Let's actually make sure that this works in runtime. Cool. So we have hello there, my name with my middle name. And then for Galen, I actually don't know if he has a middle name or not, so sorry, Galen. With him, it just prints it out as is, right? Notice that this actually saved us from an error. If I remove this This is actually has a possibility of being undefined, meaning that there's actually going to be a space between a second and third element, as well as the first and second element. So there's going to be an extra space if the person object doesn't have a middle name at runtime. So TypeScript sort of checks for that. Okay, all seems to be good. Let's actually, we actually tried it. So one thing that I want to try right now is, let's say that we want to refactor it, but not in a way that deprecates another use case, right? I want the function to be able to do everything it did before, but to add functionality to it. And so the way we can do this, my apologies. The way we can do this is actually setting up a union type, pretty similarly to mood here, right here. What I'm going to do is I'm going to say this person object at runtime can be a string or it can be a person. And if I save this, I'm pretty sure you can see from the IDE, we're getting a lot of errors, right? So we're assuming that this is of type person, and TypeScript is basically calling us out for it, saying, hey, this might take in a string. You have to account for this possibility. So let's actually do that. What I'm going to do here, I'm going to say, well, firstly, I want to change this from person to input. It just doesn't feel right to me, pretending person is a string initially. So I'll change this to input. I'll say if here I want to say use the type of operator. This is not an operator provided by TypeScript. This is actually a native JavaScript operator. So I'll say type of input equals string. So this is going to work at runtime. So if this input at runtime gives a string, I want to return here. So I'll say hello there, and I'm pretty sure you notice what's going on right now. So I'll say hello there with the input. Now, why is this not giving me an error right now? Pretty self-explanatory, but let's actually think of it logically, right? So I'll type in input here, and I'm going to hover over this. It says type person. Huh. You know, why is it saying that, right? Because we've defined this input as type string or person, right? So as strict as TypeScript is, it's also really reasonable, right? So what TypeScript is inferring basically is if we get to this line of code, in the actual build, it might be a different line, but that's besides the point. If we get after this if statement, that means we didn't return. Right? If we didn't return, that means this condition was false. And if this condition was false, this means this input is not a string, it's person by the process of elimination. So now we have a definite type after this, instead of us still having to deal with this type declaration, right? This just shows how we can take the sort of best qualities of statically typed languages, but also get the dynamic functionality of dynamically typed languages, if that makes sense. So let's try running this. Make sure we didn't break anything. We're pretty confident in that. Awesome, cool. So not every function, we're not going to be able to define the input of every function that we want to make dynamic with these unions, though. And I'm going to give you an example of when we can't do that. So let's say in the presentation, there was actually a small example, if you've seen it, this add function that we want to wrap around the traditional add operator. So why might we do this? Basically so that in TypeScript, we get a definite answer for what exactly the result of this is. You can actually do this without it, but for the sake of the presentation, I think this will be really interesting. So let's try function add. I'm just going to do with the traditional JavaScript syntax for now. A, B, I'm going to return A plus B. Now, because this is in strict mode, this is going to yell at us to give this a property value. So I'll say, for the time being, I'll do what the compiler tells me to do and say any. And I'll return a type any, right? So I want this to be able to do two things, first of all. I want this add function to be able to add numerically, but I also want it to be able to concatenate, right? So let's actually try this. Let's say my string equals add, and we want this to concatenate. Let's say hello there. Let's save this. And let's create a num. So I'll say my number is add. Let's add 1 and 2. Now this works. This is fine. But let's say that we want to do something with this, right? I'm going to make these let for the time being. My string, let's say I want to do some operations on it. Let's say, for instance, that I treat this as a date object. So I'll say get time, and I will log this. Hopefully I'll explain why I'm doing this in a bit. I'll save this. TypeScript is completely fine with this, right? In fact, if we, the issue then occurs when we run it, we see that we get a type error. So you might think, wasn't TypeScript there, to, save us from type errors? Why are we getting this now? And the reason is this keyword here, any. It's not a keyword you want to use often because this essentially opts us out of implicit type checking. So I'll have to actually go in here and declare this as a string for this type checking to actually kick in. Now this is not what we want, right? We want to, explicitly type as little as possible. This is not only, to save time and make your code a little bit more readable, but I might type this wrong. I might say this is number, right? And TypeScript would be, I'll call it a date in this case. TypeScript would be completely fine with it, right? So this goes to show just how dangerous this any keyword is. And let's actually override this to hopefully get some more interesting and useful functionality. So let's say, for instance, that I want this to take a number, and I want it to return a number. Right now, we're getting an error here. But if we look here, it says my number is declared, but its value is never read. And more importantly, it says that it's of type number. Now, we can actually use this number as is, and it'll give us the type checking that we want, right? If we set it to a string, it's going to give us an error. How do we get this for multiple things, right? Let's try using the union method. So let's say number union string. And let's do this with the others as well. So I want the return type can be a string or a number as well. The same with the other parameter. Now you can see TypeScript is giving us an error. This is because we're in strict mode. TypeScript doesn't want us to add what might be a string to a number. But let's say we ignore this, right? Now if we look at our thing here, it says string or number. And this is not what we want either, right? This is gonna basically complicate our situation. And I can't even declare this as a number because it's saying it might be a string. So you might think, how do we work around this? And one of the ways is through function overloading. So similar to how you do in C++, what I can do is I can say, declare this as a sort of header for this. I can say a number, b number, and not define it immediately. So I've declared this sort of type. I'm going to do the same for if we, in the case that we have strings. So I'm going to say type add, exactly the same, but we're going to use strings. Okay, relatively self-explanatory. Now we don't need these types, but for the compiler to be happy, I'm still going to use this any. And I'm going to remove the return type. It's not necessary. So let's save that. And more importantly, let's look at this. Now it's actually being inferred as a number, right? Now you might think like, okay, when we have situations where we have sort of dynamic input space, we would just use overloading, right? Hurrah, that's an end all solution. Let's try my string add, exact same thing here, hello there. And this is going to infer as a string, and we get the IntelliSense associated with that, right? If I go here, it's gonna give us, the tooling that we want. More importantly, it's going to, without us declaring this as a string, it's going to basically stop us from doing anything stupid. So it's going to say it has to be a string, basically. Let's try another example. So in the context of Python, this is another thing Python devs are kind of annoyed, kind of ticked off with JavaScript. There are a lot of reasons, but one of them is that when you have a list, in Python it can be a list, it can be a string, it can be anything that's ordered, like a tuple. But in JavaScript arrays, to access the last element of an array, we can't use -1. And so in Python it wraps over, but in JavaScript it doesn't. So Let's say, for instance, that we want to create a helper function. So let's say function, in this case, we want to call it last of. I'll just use JavaScript syntax here. We'll handle the type annotations later. Last of, let's say elements, and I want to return elements. Notice that we don't get any IntelliSense. This is just the result of going JavaScript style without annotating. So let's say we want to access the last element. And then we're going to normalize for zero indexing. Okay, seems to work good. We're going to tell the TypeScript compiler to calm down. We're going to say this as any, but here we know for a fact that we want an array. So I'll say an array of anything. And from here, I'll say we can return anything, right? So let's save this. Now, let's actually try to use this. So I'm going to, for the sake of not polluting the namespace, I'm going to remove that. I'll say let strings equal, I'll just create an array of strings. Hello. For the lack of originality, I'll use the same thing. And let's say let, in this case, we want numbers equal, and say 1, 2, 3. Okay, so let's actually try this out. So let's say let last num equal last of, and let's pass in number. We want to change this to plural. And say let last string, or str. We're going to say last of strings. Okay, let's save this. But similarly to before, we don't get that type annotation, right? This says this is anything, right? And if we actually annotate this, let's say number, now we have to do something extra, which, as programmers, our default should be being lazy. And secondly, we can annotate this incorrectly, right? So once again, I can do this, I can do something stupid and say this is of type person. And I can say last num dot, I don't know, first name. In this case, we can't necessarily do anything too bad. Let's say index of again. Let's save. Let's actually try running this. Now we actually get another type error. It says index of. You might see a common theme here. Like, why are we getting type errors all of a sudden in TypeScript of all languages? And the reason is, again, this any keyword. Outside of really specific contexts, like when we overloaded this function, where we had our type declarations elsewhere, you never want to use any. So you might see a problem here, right? How do we get the types to work properly with, proper TypeScript inference without having to declare arrays of everything, right? Because we aren't accessing, we aren't interacting with any particular element, right? We're just returning the last one. We don't necessarily care what the shape of this is. So how could we work around this? Well, one way, we can say last of, I don't know, this can be nums, as a number array, and this is going to return number. Now this seems fine, but then we get this error. We're not supposed to have that still. But then we get this error, right? We're trying to pass an array of strings. Okay, we have to go in and add strings case. String. And then you might think, well, what if we pass in an array of people here? Okay, then we have to account for that. You can see how this is getting really tedious, right? This should be person. How do we account for this, right? How do we make it dynamic so that we don't have to type annotate anything, and then that TypeScript infers the type correctly, but also not have to declare this for every possible type, right? I don't want to create an interface somewhere else in my application and then have to go, oh, I have to add another overload to this. The way we can do this is with generics. And so this might come as a surprise to people coming from languages like Java, because in Java, you can only declare generics and templates, whichever one you like to call it, on a class level, right? But in TypeScript, we can scope it to classes, interfaces, we can scope it to functions even. And that's what I'm going to show right now. So let's actually declare a template here. So this is where we get our dynamic functionality instead of any, and whenever possible, instead of any, use templates or generics. And so what I'm going to do is locally, I'm going to say this is going to accept an array of type T, right? And this is where TypeScript is going to interpret based on the input. And then I'm going to say this is going to return type T, right? Because we get in we input some array of any possible type, some type, and then we return an element of that type, right? So let's actually, from the start, see if this works. So let's say let last num, let's call last of. Now what I'm going to do is I'm going to say string, number. We're going to pass this as a generic to this function, and then we're going to pass in our numbers. Ready? Let's save this. And if we see here, we're getting type number. Now that's all well and good, but you might say, well, why do we pass this? Like, can't TypeScript interpret this? And if you thought that, you're absolutely amazing. That's true. TypeScript does interpret this. So whatever type it is that we pass into this, TypeScript says, okay, we're passing in a number array. It matches number with T, and it understands, oh, this type is going, so this specific function call is going to return a type T, which in this case is number, and it assigns that right now. So I can't accidentally go in here and, I don't know, like give it a type of date, because it says, hey, this is going to return a, in this case, a number. You can't do that. And we can do the same with strings. So we can say, last string, say str to keep our best practice going. Let's save, and now we get the same thing. So let's actually just triple check and make sure that we have our type annotations. Awesome, right? So I didn't have to infer this, like I didn't have to explicitly type this out, I should say. Just by using this template, this generic here, I'm able to tell TypeScript, like, hey, interpret this for me, right? I don't want to accidentally go in there and not only spend extra time, but possibly mess up my interpretation of what this function returns. You tell me what it is, right? Okay, this is well and good. What I want to show you right now is an example of how you might use generics in the form of interfaces, which is actually much more common than in the form of classes in TypeScript, at least. I'm sure it won't surprise you. Most people using JavaScript prefer not to use object-oriented programming because of its sort of limited functionality. But let's actually experiment with this. So one very common example of why we might want a generic for an interface is an API response. So I want you to think of, if you're writing a front-end application, how would you exactly give types for your services, right? So let's have this function that returns a promise that resolves to whatever it is, or it can be a callback, not necessarily too important. How do we type that, right? Do we have to give types for every return value for an API response? Well, the answer is no. We can actually create a base API response. So I'll just say API response. And this was actually an example that I showed in a real world project. This is very common. Let's actually put in some types that are in every API response, right? So let's say I'm expecting a message of type string. I'm expecting a status of, I don't know, Boolean. And so let's say I'm expecting data. This can be anything, right? Now I want your sort of TypeScript spidey senses to kick in, right? We're using any. This usually means we're shooting ourselves in the foot, right? We should not be using this. And you'd be completely right? So if I created a service that returned this, or returned a promise that resolved to it, or accepted a callback that accepted this, which you can do, then we wouldn't get any type annotations, right? So how do we work around this? And the way to do it, as I've sort of implied, is through generics or templates. So I'm going to create, once again, a localized template to this interface, and I'm going to pass it to this data property here. So now when I use this type, I'm going to pass in what exactly this API response is going to return, right? So let's actually try this. Let's say, for instance, that I want a type for a what I get returned when I'm hitting a REST API. Let's say get endpoint, and I want multiple users. So I can say type. I'll say, in this case, I'll do people API response equals, I can say API response. and I can pass in the generic of person array. Person array. So now if we actually, I'm not going to go through an example of with an actual project or actual API, but let's say I want to create a, let's say a response, people API response, and look at the, what exactly is the IntelliSense. So let's say something wrong. So this isn't what we're supposed to pass to our data property. Some message and some status. This is a Boolean, so let's just say true. If we try to save this, it's going to say type string is not assignable to type person, right? So now TypeScript is saying, hey, you need an array of people here, right? So this goes to show just how much code you can actually reuse. Very commonly, our API responses are going to have a lot of things. So we don't have to rewrite this over and over and over again. We don't necessarily even have to create a custom type for this. We can just use this inline for our services. Now that's cool. Was there anything else that I want to show you guys? Let me think. Yeah, I think if I'm not missing anything, that's about it. So just basically a tour of what TypeScript is, why it exists, why you might want to use it over something like JavaScript, a little bit of exactly what it is and more importantly, what it is not, when you might want to use it in a real world project. And then we've went over basically typing variables, in this case, creating our custom types, having optional properties. We went over functions in 3 different ways. To have sort of this dynamic input, first with just simple union operator. We went over, in the case of this add example, how to overload functions in TypeScript. And then how to use generics to get the most out of your TypeScript compiler when it comes to inference. And then finally, we went over how we can use templates or generics in the context of, in this example, an API response. Yeah, so that's just about it. I'm not too sure exactly how to end this. I think I did want to go over, oh, we have a poll. So let me try to run that, hopefully. Awesome, so thank you, Galen. So having covered all of this, what's your opinion of TypeScript? Do you think you'll try it out maybe? Do you think you'll definitely try it out? You think, no thank you? Have you already used TypeScript and do you plan to continue? And the last option is, have you used TypeScript and don't plan to continue? So I'm actually genuinely interested in what this results in. Awesome. So, okay, we have 2 classes here. So hopefully I've done a good service to TypeScript. So we have everybody that tried it saying they'll continue, and then those who haven't, hopefully will start. Yeah, this concludes the presentation. Just really quickly, some things I didn't cover. These are some of the selling points that might get some of you guys. So there are namespaces. There's support for object-oriented design patterns. For example, if you miss the private and protected variables, if you don't like the how constructors force you to say this dot something equals, if you miss decorators, if you miss enumerations, ambience is a whole other topic. But these are just some of the things we didn't cover. And coming firsthand, TypeScript has an absolutely gigantic feature set. So if you ever feel inclined, feel free to go to typescriptlang.org, go to the docs, and if you're a JavaScript programmer right now, which I'm assuming you are since we're in JS chats, you can go into this TypeScript for JavaScript programmers. And this goes pretty much into the sufficient amount of detail to get you up and running. Yeah, other than that, thank you guys for listening to this random dude talk for 2 hours. If you have any questions, you can feel free to ask me right now. Other than that, these are some of the ways you can contact me, just email and Discord for the time being. And yeah, so I'm happy to take any questions right now. I'll be the first to say that I don't know everything about TypeScript. I know pretty much I'm assuming like a fraction of it. And I'm not ashamed to say this because the feature set is absolutely gigantic. But I'll do my best to answer some incoming questions. Let's check chat.
I think everyone's left already. So
Oh, I see.
cool, cool. All right, all right. Good job, Omar. Good job. I'll stop.
Thank you, sir.
Yay!
Hey, what's up, Eugene?